Hello everyone, this is Afzalur Rahman. In our today's class, we are going to discuss about two of the important chemical reaction of haloalkanes and haloarenes. These two reactions are, one is elimination reaction and another one is substitution reaction. Okay, so first of all, I think in our last class we have discussed 8 reactions. So this will be the 9th reaction. Okay, so reaction with alcoholic NaOH or alcoholic KOH, and this reaction is an elimination reaction. Okay, so before going to this reaction, okay, now before discussing this reaction, first of all we will revisit our previous reaction, that we have discussed in our last class. We have discussed one reaction, that is reaction of haloalkanes with aqueous NaOH or aqueous KOH. Okay, so here you see I am writing this reaction once again. Suppose we have one haloalkane CH3 bond CH2 bond Cl plus aqueous NaOH. Okay, so what will be the product? In our last class we have seen that here this substitution reaction takes place. Means when these haloalkanes are treated with aqueous NaOH or aqueous KOH, then here substitution reaction takes place to form alcohol. So here you see this is Na plus OH minus. So this OH minus attacks this carbon. This is del plus del minus. So this stronger nucleophile attacks this carbon. As a result, this Cl is released. Okay, so releases as Levene group and it will attach with this sodium and it forms NaCl. Okay, so we get the product CH3 bond CH2 bond OH plus NaCl. Okay, now so this is one substitution reaction. Okay, but here you see this is aqueous NaOH, but when this alkyl halide is treated with alcoholic NaOH or alcoholic KOH, the product is different. It will not form alcohol. Okay, suppose let us write this reaction CH3 bond CH2 bond Cl plus alcoholic NaOH. Okay, then what will be the product? Here this is aqueous NaOH and this is alcoholic NaOH. Okay, now when you use aqueous NaOH you will get alcohol, but when you use alcoholic KOH you will not get the same product. Okay, so you will get an alkene. That is CH2 double bond CH2 double bond CH2 plus HCl. Okay, so here this reaction is an elimination reaction, but this is substitution reaction. Okay, that means when these haloalkanes are treated with aqueous NaOH, then substitution reaction takes place. And when these haloalkanes are treated with alcoholic NaOH or alcoholic KOH, then elimination reaction takes place. Okay, now questions can answer. What is elimination reaction? We know this elimination reaction is a type of reaction in which one or more molecules of water and HCl, HBr, okay, na, ammonia, these molecules are released from the reactant, and as a result in the product we will have double bond or triple bond, means we will get alkene or alkyne product. Okay, so this is here, this reaction is a elimination type reaction. Okay, so here dehydrohalogenation takes place. Okay, that means we can say that here this CH3 we can write CH2 bond H, and this Cl we can write Cl here. Okay, so this is del minus, this is del plus, this is del plus, and this is del minus. So here one HCl molecule will be removed. We know, and when this chlorine replaces, it takes bond with it. Okay, and this hydrogen, when it replaces it replaces without taking this bond. Okay, so here HCl molecule will be removed. Okay, so when this Cl is removed, okay, so it will take this bond with it. Okay, as a result this carbon will become electron deficient, so consequently this bond will shift to this bond. Okay, so here you will get double bond, so CH2 double bond CH2 plus HCl, CH2 double bond CH2 plus HCl. Okay, so this is one elimination reaction. Okay, so remember when this aqueous NaOH or aqueous KOH is used, we will get substitution product, means alcohol will be the product. And when this alcoholic NaOH or alcoholic KOH is used, okay, now we will get elimination product, means we will get either double bond or triple bonded products. Now question comes up, why if you use this aqueous NaOH we get substitution product? Okay, now this is alcoholic product, and if you use alcoholic, what is the difference? If we use alcoholic NaOH we get double bonded or elimination product. Okay, what is the difference? Why this we get this different types of product? The reason is that in case of aqueous NaOH or aqueous KOH, in case of aqueous NaOH or aqueous KOH, okay, this aqueous NaOH means this sodium hydroxide or potassium hydroxide, they are dissolved in water. They are dissolved in water. And alcoholic KOH or alcoholic NaOH means this sodium hydroxide or potassium hydroxide, they are dissolved in alcohol. They are dissolved in alcohol. Now, when this NaOH or KOH, they are dissolved in aqueous solution, means that when they are dissolved in water, this OH minus acts as a nucleophile. This OH minus acts as a nucleophile. So this OH minus, so it will attack this CH2 plus. Here this CH2 plus, del plus, this will act as one electrophile. Okay, so here this nucleophile will act. Okay, so in presence of aqueous solution, aqueous NaOH, this OH minus, okay, it will act as a nucleophile. So nucleophilic substitution reaction takes place. Okay, here this OH minus cannot abstract any proton, because in aqueous solution this OH minus will be surrounded by a large number of H2 molecule, okay, a large number of H2 molecule, okay, so it cannot abstract the proton, rather it will act as a nucleophile. Okay, that's why this nucleophilic reaction takes place. Okay, now what is the case in this in case of alcoholic NaOH? Now in case of alcoholic NaOH, here you see this alcoholic NaOH means this sodium hydroxide or potassium hydroxide, these are dissolved in alcohol. This alcohol may be ethanol, C2H5OH, this may be methanol. Okay, so in this methanol or ethanolic solution, okay, na, so this ethanol molecule will replace, we know these alcohols are acidic in nature, so if it replaces its hydrogen, if it releases its H plus, it will form C2H5O minus. C2H5O minus means it will form ethoxide ion. And in this solution, in the solution, alcoholic solution of this NaOH or KOH, it will have a large number of ethoxide ions, C2H5O minus ion after the release of H plus, and also it will contain some OH minus. It will contain OH minus that are released from NaOH. Okay, it will contain OH minus ion. Okay, but importantly, you see this C2H5O minus ion means this ethoxide ion are more strong base than this OH minus. They are strong base than OH minus. Okay, so that's why in this alcoholic solution, this C2H5O minus, this ethoxide ion, they will abstract a proton from this ethyl chloride, or from this haloalkane. Okay, so what you will get here you see CH3 bond CH2 bond Cl. Okay, so here in this solution, alcoholic solution, this C2H5O minus, it will abstract a proton. So from where it will abstract this proton. Here you see this CH3, we can write CH2 bond H, this H is del plus. So this C2H5O minus, this will abstract this proton. Okay, and this Cl we can write here also. This is del minus, this is del plus. Okay, so after the abstraction of this proton, this CH2 is left with one bond. Okay, now. So here you see this carbon is electron deficient. So after the abstraction of this proton, this bond will shift to this bond. Okay, this single bond. Okay, now. So when this bond shifts to this single bond, okay, now here you will get the development of double bond. Okay, now. So when there is a development of double bond, the valency of this carbon will increase. You see, before the shifting, okay, now before shifting of this bond, this carbon will have a 4 valency. Here you say 1, 2 and 2 hydrogen means 4 valency. Now when this bond shift this carbon-carbon bond, okay, now, so here you get 1, 2, 3, 4, 5 bond. And we know the valency of this carbon is 4. Okay, now it cannot exceed this valency up to 5. Okay, so when this bond shifts to this carbon-carbon bond, okay, there is a development of double bond. As a result, the valency of this carbon will increase. Okay, now when this valency of this carbon will increase, okay, now, so it will kick this chlorine bond. Okay, now, so it will kick out this chlorine. Okay, now, so here we will get CH2 double bond CH2. So here we have CH2 double bond CH2. Okay, now, so that's how these ethene molecules or these alkene molecules, they are formed. Okay, now. Okay, so this is the mechanism. How this reaction takes place. Okay, so the difference is that in case of aqueous NaOH or aqueous KOH, okay, now, this OH minus acts as a nucleophile. But in case of alcoholic NaOH or alcoholic KOH, this alcohol molecules, okay, after the release of H plus, they act as a strong base, so they abstract a proton. As a result, we get elimination product. Okay, so this is one elimination reaction. Okay, so I am writing this reaction once again. writing this reaction once again. Suppose we have CH3 bond CH2, some different reaction. Suppose bond CH2 bond Br, suppose, okay na, bromopropane. This bromopropane on treatment with suppose NaOH, okay na, in presence of C2H5OH, C2H5OH. Here we can write alcoholic NaOH, or we can write NaOH in presence of alcohol, in presence of ethanol, okay na, that means alcoholic NaOH, or rather we can write alcoholic NaOH, okay. So what will be the product now? Here also dehydrohalogenation takes place. Dehydrohalogenation means this bromine you can write here, this bromine here, this is Del minus, this is Del plus, and here we have. Now one thing you see, the bromine group which is attached to this carbon, okay na, this carbon is called alpha carbon, next carbon is called beta, next one is called gamma, like that, okay. So here you see, here at the beta carbon we have hydrogen, okay. So we have hydrogen. So when you use this alcoholic NaOH, okay, so HBr molecule, this will be removed, okay, eliminated. So this bond will shift to this carbon-carbon bond, okay. So it will form CH3 single bond CH double bond CH2. So we'll get CH3 single bond CH double bond CH2 plus HBr, okay. So this is one type of elimination product, okay. So this is elimination reaction, and this elimination product is obtained when you use alcoholic NaOH or alcoholic KOH, okay. Now here you see, in this reaction we are exclusively getting only one product. We are getting only one product, okay. Because this dehydrohalogenation takes place, there is only one way for this dehydrohalogenation. But if we take some other types of haloalkane, suppose if we use this one, CH3 bond CH2 bond CH bond Br bond CH3 bond CH3. What is the name of this molecule? The name of this molecule is 2-bromobutane. Here we have number 1, carbon number 1, 2, 3, 4. Okay, so 2-bromobutane. So 2-bromobutane. Okay na. So when this 2-bromobutane molecule, okay na, is treated with alcoholic, suppose alcoholic NaOH, okay na, what will happen? Here also this elimination reaction will take place because we have alcoholic NaOH. Okay na. So what will be the product now? Here you see, this elimination can take place in two ways. Because here you see, in this CH3 molecule, we can write this CH3 molecule as CH2H. Okay na? So here also dehydrohalogenation takes place. So here you will get one double bond. You may get one double bond here. Another way you can see, this CH2 molecule we can write CH. Here also you see dehydrohalogenation can take place. So this bond will shift to this bond. Okay na? So here you can get another product also. Okay na? So that means here you see this haloalkane, we can name this haloalkane as this is 2-bromobutane, okay na? And in this haloalkane you see we have two beta hydrogen. We know this carbon is called alpha carbon and this is beta. Similarly this one is beta. Now you see in this haloalkane we have two beta hydrogen. We have two beta carbon, and in this beta carbons different hydrogens are attached. Okay na? We have two different sources of beta hydrogen. Okay na? So when such compounds, okay na, such haloalkanes which contains more than one beta hydrogen is treated with alcoholic NaOH or KOH. Okay na? We will get a mixture of product. Okay na? And the major product will be the one which is more substituted. Or the more substituted product will be the major product. Okay na? Because here the scope of elimination we get here you see this dehydrohalogenation can take place from two sides. Okay, from this right side and from this middle portion. Okay, so we have a possibility to get two types of products. Okay, two different products. Okay, so here you see if the dehydrohalogenation takes place from this right side, we will get this product. Okay, so suppose this CH3 we can write CH2 bond H. Okay, so here this HBr molecule will be removed, so we will have double bond here. So CH3 bond CH2 bond CH double bond CH2 double bond CH2. Okay, so what will be the name? Its name is but1ene. This is carbon number 1, 2, 3, 4. Okay, now if this dehydrohalogenation takes place from this middle portion, okay na, suppose this is CH3 and we have a we have hydrogen here. So if HBr is removed from this portion, okay, so here we will have double bond. So what we are getting? CH3 bond CH, double bond CH bond CH3. So CH3 bond CH, double bond CH bond CH3. Okay, so we are getting but2ene 1 2 3 4. Okay, so we are getting but2ene. Okay, so when this type of halogenation that is which contains two beta hydrogen atoms are treated with alcoholic NaOH, okay, we will get two types of product. Okay, we will get a mixture of product. Okay, and the major product will be the one which is having more substitution, or the more substituted product will be the major product. Okay, so out of this but2ene and but1ene, which product will be the major product? Here you see this but2ene, this will be the major product. This will be the major product, and this one is our minor product. This one is our minor product. Okay, the percentage of this but2ene is 81%, and this is 19%. 19%. Okay, now because this molecule is more substituted. This molecule is more substituted. Now question comes: more substitution means, okay, now here you see more substitution means in this alkene bond CH double bond CH. Okay, now we have less number of hydrogen. More substitution means less number of hydrogen. Here you see in this alkene bond we have two hydrogen. So here two hydrogen, one hydrogen, two hydrogen. But in this you see in this alkene we have three hydrogens. Two hydrogens are attached with this carbon number 1 and one hydrogen attached with carbon number 2. Okay, now so this but2ene is more substituted, means it will have less number of hydrogen than this one. Okay, so this is major product and this one is minor product. Okay, and this generalization and this rule is called Saytzeff rule. This generalization or this rule is called Saytzeff rule, or this reaction is called Saytzeff reaction. Okay, now so this is called Saytzeff rule. Saytzeff rule or Saytzeff elimination. Okay, na? So what is Saytzeff elimination? Saytzeff elimination or Saytzeff rule says that when any haloalkane which is having more than 2 beta hydrogen atom is treated with alcoholic NaOH or alcoholic KOH, okay, na, we will get a mixture of product, and the more substituted product will be the major product. Okay. So this is all about this elimination reaction. Okay. Now see, now we are going to discuss about substitution reaction. Okay, now we are going to discuss about substitution reaction. Basically, we will discuss about this nucleophilic substitution reaction. Nucleophilic substitution reaction. Okay. So this SN reaction, okay, nucleophilic substitution reaction, this may be of two types. Okay, now basically this may be of two types. One is SN1, another one is SN2. One is SN1, another one is SN2. SN1 and SN2. SN1 means unimolecular nucleophilic substitution reaction. This means unimolecular nucleophilic substitution reaction, and SN2 means bimolecular. SN2 means bimolecular nucleophilic substitution reaction. Okay. SN1 and SN2. Okay. Now this in this SN1 reaction, the order of this reaction is 1. Order of this reaction is 1. Okay, and in the SN2 reaction, this order of this reaction is 2. Okay, now, or the molecularity of this reaction is 1. We have the molecularity of this reaction is 2. Okay, now, so this SN1 reaction, this reaction takes place in 2 steps. Okay, now this is number 1. Order of the reaction is number 1. Number 2, this reaction occurs in 2 steps. Okay, now 2 steps. This SN2 reaction, this occurs in a single step. In a single step. Okay. This reaction involves the formation of carbocation. SN1 reaction involves the formation of carbocation. carbocation, and this one involves the formation of transition state. Okay, this reaction is a slow reaction and this reaction is a fast reaction. Okay, this is a slow reaction and this is a fast reaction. Okay, here in this reaction, the reactivity of this alkyl halide, the reactivity of this haloalkane is 3 degree is greater than 2 degree is greater than 1 degree. But in case of SN2 reaction, the order of reactivity of this haloalkane is 1 degree is greater than 2 degree is greater than 3 degree. Okay. Next, in this SN1 reaction, it involves the retention of product. It involves the retention of product. We will get retention product, but here you will get inversion product. Here we will get inversion product. Okay now. Now what is retention and what is inversion? Okay now. Retention means if the configuration of bonds before and after the reaction remains same, then this is called retention. And inversion means if the configuration of this bond changes. Okay now, before and after the reaction, if the configuration of this bond is not same, then this is called inversion. Okay now. Here you see, here for this reaction, the rate of this reaction will be K into 3 degree alkyl halide Rx or 3 degree haloalkane, and the rate of this reaction will be dependent upon this 3 degree, only on this 3 degree alkyl halide. And for this reaction, the rate of this reaction will depend upon this 1 degree alkyl halide, 1 degree Rx or 2 degree Rx, and also upon this nucleophile. This OH minus is nucleophile. Okay. So this is some of the information or some of the differences between this SN1 and SN2. This SN1 is called unimolecular nucleophilic substitution reaction. SN2 is called bimolecular nucleophilic substitution reaction. Here the order of this reaction is 1, order of this reaction is 2. Also the molecularity is 1, molecularity is 2 for this one. And now for this SN1, it occurs in 2 steps. Okay. But this is a single step reaction. Okay. Here in this reaction, it involves the formation of carbocation. Okay now. The first step involves the formation of carbocation, and then after that nucleophilic attack takes place. Here, but here in this case, it does not. It occurs in a single step. And it involves the formation of transition state. Here only a transition state will form, and after that the product will be formed. Okay. After that, this reaction is comparatively slow reaction, and this is a fast reaction. Okay. In this reaction, the reactivity of this alkyl halide will be 3 degree alkyl halide or 3 degree haloalkane. This reactivity of this 3 degree haloalkane is more than 2 degree than 1 degree. But in this case of SN2, the order will be the reverse. 1 degree is greater than 2 degree greater than 3 degree. Okay. Here, this SN1 reaction involves the retention of product. Okay na? But SN2 reaction involves the inversion of product. Here the rate of this reaction depends upon only upon the 3 degree alkyl halide or haloalkane. But here in case of SN2 reaction, the rate of this reaction depends upon the 1 degree alkyl halide and also upon this nucleophile. Okay na? So now we are going to discuss about this SN1 and SN2. Okay na? Unimolecular nucleophilic substitution and bimolecular nucleophilic substitution reaction. Okay. Here you can take the screenshot also. Now see, now we will discuss about SN1 and then we will discuss about SN2. Here you see SN1. SN1 means unimolecular nucleophilic substitution reaction. Unimolecular nucleophilic substitution reaction. Okay na? So here we have seen that in case of SN1 reaction, the reactivity of this 3 degree alkyl halide is more than 2 degree than 1 degree. Okay na? So here we will take 3 degree alkyl halide. So in this reaction, when this 3 degree alkyl halide is treated with aqueous NaOH or aqueous KOH, it will form 3 degree alcohol. And in this reaction, the reaction will proceed by following this SN1 mechanism. Okay. So here let us take one reaction. Suppose CH3 bond CH, bond CH3, not CH, C, bond CH3, bond OH, bond Cl. Suppose bond Cl. This is 3 degree alkyl halide, 3 degree alkyl halide, 3 degree Rx or 3 degree haloalkane. Okay. Why this is 3 degree? Because the halogen group which is attached to the carbon is attached with 3 alkyl groups. Okay, that's why this is 3 degree. When this 3 degree alkyl halide is treated with aqueous NaOH or aqueous KOH, aqueous NaOH or aqueous KOH, it will form 3 degree alcohol. It will form 3 degree alcohol. Okay. So here you see Na plus and OH minus. So this OH minus will attack this carbon. Okay. So this OH minus will substitute this carbon. Okay. And this Cl will attach with this Na. So it will form NaCl. So we will get CH3 bond C, bond CH3, bond CH3, bond OH plus NaCl plus NaCl. So this is 3 degree alcohol. 3 degree alcohol. This is 3 degree alcohol, and the reaction process by following this SN1 mechanism. By following this SN1 mechanism, and previously we have discussed that this SN1 reaction involves takes place in 2 steps. Okay, now. Okay, so the next one is mechanism of this reaction. Mechanism of this reaction, step 1. Step 1. Okay, now. This step 1 involves the formation of carbocation. Formation of carbocation. What is carbocation? Carbocation means carbon with positive charge. This is called carbocation. Now let us take this 3 degree alkyl halide, that is CH3 bond C, bond CH3, bond CH3, bond Cl. Okay. So here you see this is del minus, this is del plus. Okay, now. So in this step, the formation of 3 degree carbocation takes place. Okay. So here this Cl minus will be released as a leaving group. Okay. So we will get CH3 bond C, bond CH3, bond CH3 plus Cl minus, because when this Cl is released, okay, now it will take the bond with it. Okay, so as a result this carbon will become deficient, electron deficient, so this big carbon becomes C plus. Okay, or we can write it like that. Okay, CH3 thrice C plus 3 degree carbocation. Okay, this is C degree 3 degree carbocation, 3 degree C plus. Okay, then step 2. Step 2 is attack of nucleophile. Step 2 is attack of nucleophile. What is the nucleophile here? Here you see this OH minus, it is the nucleophile. OH minus is the nucleophile. Okay, now you take this 3 degree carbocation. This 3 degree carbocation, you take this one, CH3 bond C, bond CH3, bond CH3 plus. Okay, and here OH minus. This OH minus is nucleophile. OH minus is nucleophile. Now you see this carbon requires 1 electron because it is deficient of electron. So this OH minus, it will attack this C plus to form the product. So it will form CH3 bond C, bond CH3, bond CH3, bond OH. Okay, so this is 3 degree alcohol. 3 degree alcohol. Okay, so here you see in the first step the formation of this carbocation takes place. Okay, and the next step is attack of nucleophile. Okay, so this is slow step. This is slow. Okay, now, and this second step is the first step. Okay, so here this nucleophilic attack takes place to form the product. Okay, so here you see here the retention of product takes place. Here the retention of product takes place. Why this retention product? Because this reaction is a slow reaction. Okay, now. Okay, so this here you see why this is retention product, because the configuration of this OH bond, configuration of this bond remains same. Okay, now, because this leaving group is okay, now leaving group, we are removing this leaving group from the right side now, and the and the incoming group that is attached to the in the right side, in the same side. Okay, now it is attaching in the same side. That's why the configuration of this bond remains same. Okay, now, so that's why this is called retention product. Okay, and in this reaction, the rate of this reaction depends upon both this 3 degree alkyl halide and this nucleophile OH minus. Okay, so the rate of this reaction here I am the rate of this reaction here. In this reaction, the rate of this reaction is equal to K into 3 degree alkyl halide, there is 3 degree Rx, okay now, or you can say 3 degree CH3 thrice Cl and OH minus, CH3 thrice Cl, okay now. So it will depend upon this, since it is unimolecular nucleophile substitution reaction, so the rate of this reaction will depend only upon this 3 degree alkyl halide, okay. So this rate of this reaction is equal to K into 3 degree alkyl halide, okay, 3 degree CH3 Cl Rx. So this reaction takes place in presence of polar protic solvent. In presence of this SN1 reaction takes place in presence of polar protic solvent, means in presence of water, in presence of alcohol, okay na, like that. And this SN2 reaction takes place in presence of polar aprotic solvent like DMS or DMF, okay na. So this is all about this SN1 reaction. Now we are proceeding towards SN2 reaction, okay. Now we are proceeding towards SN2 reaction. In case of SN2 reaction, we have seen that the order of reactivity of this SN2 reaction is 1 degree is greater than 2 degrees greater than 3 degree, okay na. Means in case of SN2 reaction, 1 degree alkyl, we can take this 1 degree alkyl halide because with this 1 degree alkyl halide, the reaction will be a fast reaction and favorable one, okay. So next one is SN2 reaction. SN2 reaction means bimolecular. SN2 means bimolecular nucleophilic substitution reaction, okay. So in this reaction, when this primary alkyl halide, suppose let us take one reaction, CH3 bond CH2 bond Cl. So this is ethyl chloride or chloroethane. When this is treated with aqueous NaOH or aqueous KOH, it will form corresponding alcohol. Okay now. So what will be the product now? You will get suppose I am writing suppose you will get CH3, or you can write OH bond CH2 bond CH3 plus NaCl, okay na. Here this NaCl will be removed and this OH minus will attack this CH2. So it will form CH3CH2OH, okay na. So I am writing this in reverse way. Why this is in reverse way? Because here in this SN2 reaction, the inversion of product takes place. Means here the configuration of bond does not remain same, okay na, before and after the reaction. So this is the reaction here. This is the reaction. Now what is the mechanism? Now here is the mechanism. We have seen that this SN2 reaction is a fast reaction and it takes place in a single step. Okay na. So what is the mechanism? You see here, I am writing this mechanism. CH3 bond CH2 bond Cl. This is del minus, this is del plus, and here we have Na plus OH minus. This OH minus is the nucleophile, okay. So here we have OH minus, okay. So here you see, in this step, this is del plus, means this is electron deficient. So this OH minus will attack, but this OH minus cannot attack from this side, from the front side. Rather, it will attack from the back side, because if it tries to attack from this front side, okay, there will be electronic repulsion. Because this chlorine is having 6 electrons, okay na, and this OH minus it also is having some electrons, okay. So there will be some electronic repulsion. So this is not the convenient way. Rather, it will take from the back side, okay. So here I am writing this OH minus. So here this back side attack takes place, okay now. So this OH minus, I am writing here, this OH minus attacks from the back side. Or when this OH minus attacks this carbon, the valency of this carbon will attack, the valency of this carbon will increase. As a result, it will shift. This chlorine group will be removed as a leaving group, okay. So here you see what will happen in this reaction. We have seen that there is a transition state. There is a formation of transition state. So a transition state will form. So what will happen here? You see CH3 bond C. Here we are writing CH3 bond C. This CH3 bond C. Along with this C, we have 2 hydrogen. So here 1 hydrogen, another hydrogen, and here you see this OH minus is attacking. So you can write this OH minus. Here OH minus, okay. And when this OH minus will attack, this Cl bond will break. So I am writing both in a dot line, okay na. So that time while this carbon oxygen bond forms, this carbon chlorine bond will break. This carbon chlorine bond will break, okay na. So this is transition state. Okay na. So after a while, this carbon oxygen bond, carbon OH bond will form, and this Cl minus Cl will be removed, okay. And Cl will attack with this. You will attach with this Na and will form NaCl. So this is transition state, and after that it will form CH3 CH2 OH, CH3 bond CH2 bond OH. Okay now, why I am writing this in this reverse way? To indicate that this reaction is it forms an inversion product. Okay, so this is ethanol, this is ethanol, so this is alcohol. Okay, and here this Cl minus Cl minus, so it will attach with Na to form NaCl. So here you see in this reaction inversion product or inversion of product takes place, because here you see, first of all, before the reaction the configuration of this bond Cl na, this is in the right side, but now this configuration of this bond changes. Okay, in the reverse way. Why the configuration of this bond changes? Because this is a fast reaction. This is a fast reaction. Both this nucleophilic attack and this release of this Cl minus takes place in a single transition state. In a single transition state. Okay, now the time in which this carbon bond oxygen OH bond forms, at that time this carbon chlorine bond breaks. Okay, this chlorine Cl minus will be removed. Okay, so that's why this transition state takes place. Formation of this transition state takes place. Okay, now so this is how this product forms. Okay, so in this reaction we have seen that the rate of this reaction is dependent upon both the reactant, both this alkyl halide and the nucleophile. So rate will be this dependent upon CH3 CH2 Cl will depend upon this CH2 CH2 Cl and this OH minus Okay, that's why this is bimolecular. That's why this is bimolecular nucleophilic substitution reaction. Okay, so this is the reaction and this is the mechanism of this SN2 reaction, bimolecular nucleophilic substitution reaction. Okay, so far now what we have seen that in our today's class what we have discussed. We have first of all we have discussed about elimination reaction, then we have discussed about substitution reaction. Okay, nucleophilic substitution reaction. We have seen that in case of elimination reaction, when these alkyl halides substitute with alcoholic NOH or alcoholic KOH, okay, na, elimination reaction takes place to form the product. Okay, if this haloalkane does not contain two beta hydrogens, okay, na, so it will form only one product. But if it contains more than one, if it contains if it contains two beta hydrogen, then this elimination can take place in two ways. Okay, to form two different products. Okay, in this case the more substituted product will be the major product, and this generalization is called Saytzeff elimination or Saytzeff rule. Okay, after that we have discussed about nucleophilic substitution reaction. This can take place in two ways. One is SN1 and another one is SN2. This SN1 means unimolecular nucleophilic substitution, SN2 means bimolecular nucleophilic substitution reaction. Okay, now this SN1 reaction takes place in two steps, SN2 reaction takes place in one step. This SN1 reaction involves the formation of carbocation, this involves the formation of transition state. Okay, this SN1 reaction is a slow reaction, this SN2 reaction is a fast reaction. Okay, now here this in case of SN1 reaction the order of this reaction is 2, SN2 reaction order of this reaction is so in SN1 reaction the order of this reaction is 1, SN2 reaction the order of this reaction is 2. Okay, and in this SN1 reaction the rate of this reaction is dependent upon the only one 3 degree alkyl halide, but SN2 reaction the rate of this reaction depends upon both this 1 degree alkyl halide and the nucleophile also. Okay, here in case of SN1 reaction retention of product takes place, but in SN2 reaction inversion of product takes place. Okay, and after that we have seen the mechanism, reaction and mechanism of both SN1 and SN2. Okay, so here you see in case of SN2 reaction the reactivity will be the reactivity of Rx, reactivity of alkyl halide will be 1 degree is greater than 2 degree is greater than 3 degree. 1 degree is greater than 2 degree is greater than 3 degree. Okay, in case of SN2, and in case of SN1 it will be 3 degree, then 2 degree, then 1 degree. Okay, so for today's class up to this, okay now, so we have already discussed all the chemical properties of these haloalkanes and haloarenes. Okay, now so we have just completed the whole topic of this haloalkanes and haloarenes. In our next class we will be discussing about haloarenes and its chemical and physical properties. Okay, so thank you everyone.